Hey guys, today we're going to start looking at the absolute value function. Now the absolute value function looks like this. It will always look like V. The vertex is located at 0, 0. This is basically the middle of your graph and like the main point. Now reference points are considered the points that are located on our parent function. This is the parent function of absolute value of x, since there are no transformations applied. There are no stretches, no shrinks, no translations, no reflections. So our reference points would be any points located on this original graph. If you go along the graph, we see that we have a point at 1, 1 and negative 1, 1. These are going to be the reference points that we use most of the time. However, you can use other reference points such as 2, 2, negative 2, 2, 3, 3, negative 3, 3, and so on and so forth. You could basically use whatever reference points as long as it's located on our original function. Now let's have a look at how we would graph an absolute value function. And it's the same way that we've been working with in terms of our quadratic or any other functions if there are transformations applied. When we look at this particular equation, we have a 4, the negative 5, and the negative 2. Now this 4 is being multiplied and it is on the outside. Therefore, that is a vertical stretch of 4. Additionally, we have this negative 5 that is on the inside of my absolute value. Therefore, it went to the right 5. And finally, this negative 2 on the outside means that the absolute value function went down 2. Now we would write the rule. Remember that anything that is on the inside affects your x's, and we do the opposite. That's why it went to the right 5. So for the rule for the x's, we would say x plus 5. Now the rule for the y's is anything that's left over on the outside of the absolute value. And we have a 4 that is being multiplied and then a minus 2. Therefore, the rule for the y's would be 4y minus 2. Now these are the reference points that we initially found at the beginning. Obviously the vertex you're always going to use, and then negative 1, 1, and 1, 1. And I just realized I put a negative 1 when it's a positive 1. Okay, so now we're going to plug in these points into our rule. If I plug in x is negative 1, we get a new x of 4. And if I plug in a 1 for the y, we get 4 times 1, which is 4, minus 2 is 2. When I plug in 0, 0, 0 plus 5 is 5. And 4 times 0 is 0, minus 2. And finally, when I plug in 1, 1, 1 plus 5 is 6. And 4 times 1 is 4, minus 2 is 2. So these are my new points, and I'm just going to go ahead and plot that. So we have 4, 2, 5, negative 2, and 6, 2. Once you have your 3 points, remember that our graph looks like a V. So we would just connect. And this would be my absolute value graph. Let's look at a couple more examples. Now here we have g of x is equal to the absolute value of negative 1 over 2 x plus 3 and then plus 1. So we're going to go ahead and write our rules for the x's and our rules for the y's. The rule for the x's, remember it's anything inside of the absolute value, and you're going to do the opposite except for the negative. So this would be negative 2x minus 3. And for the y's, it would be y plus 1. Now we use our reference points, the same ones that we used the last time, negative 1, 1, 0, 0, and 1, 1. And we're going to plug it into our rule. When you plug in negative 1 for the x, negative 2 times negative 1 is a positive 2. Minus 3 is negative 1. And when you plug in 1 for the y, 1 plus 1 is 2. Now when we plug in 0, negative 2 times 0 is 0, and 0 minus 3 is negative 3. And when you plug in 0 for the y, 0 plus 1 is 1. Lastly, we plug in 1, 1. Negative 2 times 1 is negative 2, minus 3 is negative 5. And then 1 for the y again, 1 plus 1, 2. So these are my new points, and I'm going to go ahead and plot that. So we have negative 1, 2, negative 3, 1, and negative 5, 2. And this would be my graph. Remember, it should always look like a V. Now let's look at this one here. When we write our rule, we have this negative 1, for the inside we have x minus 1, so the opposite would be x plus 1. Now for the outside, we have negative 1 over 3y plus 4. Now I put here as a note, you can also use reference points other than the ones we've discussed, such as negative 1, 1, and 1, 1, so that we can divide easier. If you look at the rule for the y's, we're going to have to divide the y's by 3. It's easier to divide 3 by 3 than it is to divide 1 by 3, because then we get a decimal and that's kind of hard to plot. So instead of using negative 1, 1, I'm going to use negative 3, 3, always the vertex, 0, 0, and instead of 1, 1, I'm going to use 3, 3. Now I'm ready to start plugging in my points. When I plug in negative 3, 3, negative 3 plus 2 is negative 2. Now when you plug in the y for the 3, negative 1/3 times 3 is the same thing as saying 3 divided by the negative 3, which is negative 1. And negative 1 plus 4 is 3. When you plug in 0, 0, 0 plus 1 is 1, and 0 divided by anything is 0, so plus 4 is 4. And finally, for 3, 3, 3 plus 1 is 4, and negative 3 divided by 3 divided by negative 3 is negative 1, and negative 1 plus 4 is 3. So these are my new coordinates, and this is much easier to plot than if I were to use negative 1, 1 and 1, 1, end up with decimals. So here we go. Negative 2, 3 is our first point, then 1, 4, and finally, oops, I put the wrong spot, my bad. So 1, 4, and 4, 3. And remember, this is a V, and it is upside down because we have that negative that is on the outside, meaning that we have a reflection of the x-axis. Oh, I came out a little crooked. So that's why it's upside down. Now, when we're graphing an absolute value equation, we're going to do the same thing that we were doing before. We are going to graph the absolute value part first. So ignore the equal to part until after. So we're going to look at this part of my equation, the 2 absolute value of x minus 5 minus 4. We're going to go ahead and do what we just did. So we have xy. Now the rule for the x would be x plus 5, and the rule for the y is 2y minus 4. We're going to use our regular reference points, negative 1, 1, 0, 0, and 1, 1. Remember, we're only going to alter our reference points if we're dividing by something that makes it difficult to divide. So here we go. We're going to go ahead and plug in these points into our rules. Negative 1 plus 5 is 4. Then when you plug in 1 for the y, 2 times 1 is 2, minus 4 is negative 2. When we plug in 0, 0, we get 5. 2 times 0 is 0, minus 4, negative 4. And when you plug in 1, 1, we get 1 plus 5, which is 6. And again, 2 times 1 is 2, minus 4, negative 2. So these are my new points. I'm going to go ahead and graph that. So 4, negative 2, so right here. Then we have 5, negative 4. So if you notice our axis, it goes by 2. So 5 is right in between 4 and 6. So we're going to go 5, negative 4, which is right in the middle. And then we have 6, negative 2. So now it's important to follow the pattern for your absolute value. If you notice that the slope here is half to the right and up 1. So for each one, I'm going to just go ahead and follow that pattern. So that way my solution is evident. You'll see that when we graph the solution. That's pretty good. And now we're going to go ahead and connect. And we have our absolute value graph. Now we see that it equals to 2. This is a y value. Okay, so we're going to go to y is equal to 2, and you're going to draw a horizontal line. Okay, and I'm following my steps here. So the first step, which was to graph the absolute value function, we did. Now we graph the constant, which is the 2, and our x values are where the functions intersect are the solutions. So we have an intersection here and here. And those x values are 2 and 8. So these are my solutions. Let's try this one more time. We have here negative absolute value of 2x plus 2 plus 3 equals to 1. So remember that we're only going to graph the absolute value part first. So we're going to write our rule for the x's and the rule for the y's. Now if you look inside, we have this 2 that is being multiplied, but we have to do the opposite. So 1/2 x minus 2. And then for the y's, we have the negative and the plus 3. So this will be negative y plus 3. Now for our reference points. It looks like I'm going to have to take my x values and divide by 2. So instead of using negative 1, 1, I'm going to use negative 2, 2, since it's going to be easier to divide. And then that means instead of 1, 1, I'm going to use 2, 2. And now I'm ready to plug into the rule. When you plug in negative 2, half of negative 2 is negative 1. And negative 1 minus 2 is negative 3. Then when you plug in 2 for the y, we have negative 2 plus 3, making it 1. When you plug in 0, 0, half of 0 is 0, minus 2 is negative 2. And negative 0, which is just 0, plus 3, 3. Lastly, when you plug in 2, half of 2 is 1. 1 minus 2 is negative 1. And negative 2 plus 3 ends up with 1. So these are my new points. And now I'm ready to graph. So we have the point negative 3, 1, negative 2, 3, and negative 1, 1. And from here, I'm good to connect. Remember, absolute value v. And this is my graph. We have that the absolute value equation is equal to 1. So I'm going to draw a horizontal line where y is equal to 1. And I'm going to take note of those points of intersection, which are here and here. So my solutions would be x is equal to negative 3 and negative 1. Let's try one more, just to make sure that we understand. We have 2 absolute value of x plus 4 minus 5 is equal to negative 6. So let's write our rules. The rule for the x's would be x minus 4. Whoa. Let's try this one more time. Sorry about that. Okay, I got ahead of myself. So we have xy. Now the rule for the x's would be x minus 4. And the rule for the y would be 2y minus 5. Here I don't have to divide anything, so I'm going to use my regular reference points, negative 1, 1, 0, 0, and 1, 1. And I'm going to go ahead and plug it in. When I plug in negative 1 for the x, negative 1 minus 4 is negative 5. And when I plug in 1 for the y, 2 times 1 is 2, minus 5 is negative 3. When I plug in 0, 0, 0 minus 4 is negative 4. And 2 times 0 is 0, minus 5 is negative 5. Lastly, when I plug in 1, 1, 1 minus 4 is negative 3. And then once again, when I plug in 1 for the y, I get negative 3 as well. So these are my new points. I'm ready to graph. We have negative 5, negative 3, negative 4, negative 5, and negative 3, negative 3. This is my absolute value graph. Now I see that it equals to negative 6. When I draw that horizontal line at y is equal to negative 6, I see that there are no points of intersection. And this is because there is no solution. So your solutions are always where your graph intersects that horizontal line. So if it does not, that means that there are none. Now let's look at how to graph a more complicated absolute value equation. We have here the absolute value of x minus 1 minus 4 is equal to negative 1 over 2x plus 1. Now we're going to do the same thing we did before. We're going to graph the absolute value part first, and then we'll worry about that line. So we have absolute value of x minus 1 minus 4. I'm going to write out my rules. The rule for the x's would be x plus 1, and the rule for the y's would be y minus 4. I'm going to use my regular reference points and plug it in. When I plug in negative 1, 1, negative 1 plus 1 is 0, and 1 minus 4 is negative 3. When I plug in 0, 0, 0 plus 1 is 1, and 0 minus 4 is negative 4. And when I plug in 1, 1, I get 1 plus 1, which is 2, and 1 minus 4, which is negative 3. So let's go ahead and graph that. I have the 0, negative 3, 1, negative 4, and 2, negative 3. Now remember to follow this pattern, right? So I went 2 up and 2 right. So I'm going to keep doing that to make sure that I have a good graph. Otherwise, the solution could be difficult to see if your absolute value equation is kind of wonky. And that's good. Now, to graph the second part here, negative 1 over 2x plus 1. As I wrote here, this is a linear function. Y is equal to mx plus b. So what that means is we're going to graph this line. Remember that we use the y-intercept first. So I'm going to put my first point at the y-intercept, which is at 1. And the slope here is negative 1 over 2, meaning I'm going to go down 1, right 2. Down 1, right 2. Down 1, right 2. And then the same thing but in the other direction, meaning up 1, left 2. And this is my line, negative 1 over 2x plus 1. Now we're going to take note, of course, where it intersects, which is here and here. So my two solutions are going to be x is equal to negative 8 and positive 4. Let's look at one more example. We have negative absolute value of 2x plus 1 plus 4 is equal to x plus 2. So let's start with graphing the absolute value part. So I'm going to write my rules. The rule for the x's would be half x minus 1, and the rule for the y's would be negative y plus 4. Because I'm going to have to divide my x's by 2, I'm going to use the reference points negative 2, 2, 0, 0 always, and 2, 2. Now we're ready to plug in. Negative 2 divided by 2 is negative 1, and negative 1 minus 1 is negative 2. Then when I plug in 2, we have this negative, so negative 2 plus 4 is 2. When I plug in 0, 0, half of 0 is 0, minus 1 is negative 1, and 0 plus 4 is 4. Finally, when I plug in 2, half of 2 is 1, 1 minus 1 is 0, and negative 2 plus 4 is 2. So this is for my absolute value. I'm ready to graph. We have negative 2, 2, negative 1, 4, and 0, 2. This is my absolute value part of my equation. Now I'm ready to graph the x plus 2. When I look at the line, the 2 is my y-intercept. And then my slope is 1, meaning go up 1, right 1. And in the other direction, it would be down 1, left 1, down 1, left 1. And we would connect. Now we can see that our intersections are here and here. So our solutions are going to be x is equal to 0 and x is equal to negative 4. And that's how you graph absolute value equations.